Hey guys, welcome back to another video on neural networks. In this video, we're going to be talking about neural net vocabulary. And this is actually extremely important because when you're doing tutorials here on my channel or anywhere else, they use a lot of advanced vocab that might throw you off and not help you understand the things fully. So this video will help you understand a lot of the main vocab words that are used and what they are used for, and they have definitions. Also, if you want to check out these definitions and all the slideshow presentation, it's the comments are in the description below, so it'll have all the presentation and words and definitions and things like that. Now, the definitions for some of these words come from Google developers on their site or sometimes Wikipedia, but links to their page is in the comments, and also there's a page with all the terms and definitions, which is going to be this slideshow. Now, the first word is data. This is the information that a neural network is run on, and data can be expressed in many different ways. It can be expressed in a CSV, comma separated values, like an Excel sheet, like this one, or it can just be a notepad, or it can just be a regular spreadsheet that's not CSV. Many things, but data is the far most important thing here. The label. This is the output of a neural network. So if you have a neural network like this, you have the input, hidden, and output. This is the label output. Now this is the input. The feature is the input, which is these. And then a layer is just one of these values. So there's a set of neurons in a neural network that process is in a set of input values or the output of those neurons. That's the Google definition. So in other words, it's just one of the layers that either does computation or takes an input or displays an output. Now this is a hidden layer, and the hidden layer is there could be many of these in which all the calculations are performed. Now, linear regression. It's a type of regression model that outputs a continuous value from a linear combination of input features. So say you have a bunch of input features, which is the data, all this, blue dots, and then there's a regression model, and there's a couple of algorithms you can do and implementations you can do to create a best fit line to predict values. So that's also really cool. It's not as much of neural network as it is AI, but it's very important, but you probably won't need it for neural networks, but it's good to know this. Weights. So when you try to do calculations, there's a coefficient of the feature, which is the input in a linear model, or an edge in a deep neural network. So basically, this is what you multiply the features by in order to get the outputs, which is done in the hidden layer. So the coefficient is what you're looking at. So this is a weight. A matrix. In matrix, a matrix is a rectangular array of numbers, symbols, or expressions arranged in row and column. This is Wikipedia's math definition of a matrix. So this is one way a matrix could be expressed as a 4 by 4 array of arrays, numbers, and expressions. So we're just using zeros and ones, which is binary, and this is just one of the ways it can be expressed. Loss. The loss function is based on the absolute value of the difference between the values that a model is predicting and the actual values of the labels. This is another Google developer definition. Basically, what this saying is how off and how inaccurate your prediction is. And this picture kind of shows the robotic error, which is very minimal because it's using a bunch of different functions, and human error, which can be very bad because, well, it's a human error. But loss is basically just the difference of how good your robot is compared to the actual accuracy. Gradient descent. This is a bit hard to understand, but let's do my best to explain it. A technique used to minimize loss by computing the gradients of loss with respect to the model's parameters conditioned on the training data. This is another one of those Google developer definitions, which is pretty hard to understand. So basically what this is saying is it's a technique to minimize loss, which means so you have a prediction, like the coefficient, the weight, and how off that is. And it can be expressed into this parabola shape, which is a quadratic graph. And this is just to use a technique to minimize it and try to get to the exact value by going down this parabola. So as you see, it's very off up here, but if you go down a little bit, it gets closer, in the winter. So there's techniques and algorithms to make a perfect gradient descent. It'll never be perfect, but it'll be very close. For example, if you make it extremely big, it can go all the way here on the other side and can never really reach the winner because just how big the margins of the gradient descent are. But if you make it really small, you can eventually get to the winner. And there is a playground for that you can do on the Google developer site, which I'll leave a link to in the description below. Training. This is to run the neural network in attempt to prove accuracy. So basically, how many times are you going to run the program and do the gradient descent to get the perfect value or almost perfect value? And this is showing a bunch of iterations. An activation function is a mathematical function to introduce nonlinear computations in order to calculate loss. So this is the way to calculate loss, and this is different from gradient descent. Gradient descent is to actually how much are you going to go down and how low are you going to go. This is just to compute the loss and calculate the loss with nonlinear computations. So this is a sigmoid function, which is one of the popular activation functions. Back propagation is to adjust the weights, to go back and change the weights and run it in the new training iteration. Clipping, to trim the data set to make it shorter and take out outliers. So you can have an outlier all the way over here, which completely throws off your data, even though it really shouldn't be there. I mean, it's real data, but it really shouldn't be there, and it could just hurt your program. But now if you clip it, it's a lot easier to do the coding and a lot easier to make good predictions. Depth, the number of layers in a network. So this neural network is very large. It's pretty deep. And it has 1, 2, 3, 4, 5. So its depth is 5. And this includes the input and output layer. And that's about it. If you have any questions, please leave them in the comments below. And check out the links I talked about in the description below. Also, for all these pictures, including this one, there is in the speaker notes, which you'll see when you get the presentation. It's in the links for these pictures are there. So that's about it. I hope you learned a lot from this video. It was a bit difficult to make. And if you have any other questions, please ask in the comments below. And in the next video, we're going to talk about the actual steps into building a neural network. All right, I'll see you in the next video.